Welcome back, food science. It's been a couple days since we last talked. I hope you had a good weekend. Today we're going to continue talking about leavening agents. Last notes that you took a look at chemical leaveners, and we talked a little bit about how chemical leaveners are acids and bases. And we didn't get into anything really more than chemical properties of acids and bases. Acids are sour, bases are bitter. We talked about their pHs a little bit, and that's what we're going to actually get into a little bit more today. So we are going to take a look more at some of the properties of pH and what that means. And when you look at information about pH, you can make some informed decisions about what you should be eating and maybe what you shouldn't be eating. So when we get started, the quantity of hydrogen ions given off in solution by an acid is reflected by the substance's pH. So I'm going to actually go back just a little bit. Now, we talked about how in acids that the H's come off of their chemical structure, and the actual concentration or the amount of ions that come off the H concentration basically, if you do a mathematical calculation, technically what you do is you take the negative log of the concentration of the hydrogen ions, and if you take that, put it into your calculator, and hit the equal sign, you get a value called the pH. So the pH is technically a logarithmic calculation that's done with the hydrogen ion concentration. And the way it works is that the higher the concentration of H plus, the lower the pH is going to be. So on the pH scale, most scales are labeled from 0 to 14, and we're going to show that in just a second. But on the scale, 7 is considered neutral. And the most common thing that you think that has a pH of 7 is water. So water has a pH that's neutral, and then acids go to the lower side, anything below 7, and bases are above 7. So when we talk about them, you should be able to look at a substance and figure out if it is an acid or a base based off of its pH. Okay? Now, because the pH scale is a logarithmic scale, what that means is that anytime you see a change in a pH, whether you're going up or going down, that is going to be a change in 10-fold of the concentration. And we'll go over what that means, but essentially, if I go from something that's got a pH of 5 to a pH of 6, there is going to be a change where the pH of 5 actually has 10 times the concentration of the solution that has a pH of 6. Okay? And that's because it's a negative log and not a positive log value. And acids and bases are essentially opposites of each other. So if an acid adds H plus to water, a base adds OH minus. Okay? So they effectively neutralize what we say or cancel each other. Most foods tend to be acidic, and I have a rather large sheet that I'm going to be giving to you about all the different pHs of some really common foods, and most foods tend to be more on the acid side of things. So if we think about our pH, most foods tend to be more on the 7 or lower side. This is maybe a little bit of a blurry picture, but I like the way that this is kind of structured, and I'd like you to get something similar to this put into your notes. It does not have to be perfect, but it should be pretty close to this. So on this particular pH scale, oh, and your scale doesn't have to be colored, but you do want to get the numbers in there. On this particular scale, it goes from a 1 to a 14. But the reason why they have those scales set up this way is because most substances that you guys are going to encounter are going to be within these pH numbers, a 1 through a 14. You should know, though, that there are some things that have pHs that are less than 1 or pHs that are higher than 14. And the way that I kind of think about things when I'm dealing with pH is that 7 is my set point, and that's the middle. And the way that it works is that the further towards the extremes of the scale, so a 1 or to a 14, the more extreme you get with those, the more dangerous those things are going to be for you to come into contact with. So something that has a pH of a 5, a 6, or even a 4 is fairly weakly acidic, and you should be able to deal with that in relatively high amounts without any consequences. And the same thing for things that are weakly basic. Another word that we'll use for basic sometimes is alkali or alkaline. So just be prepared to kind of see both of those, they're used interchangeably. Okay? So anything that's kind of in this first, or these middle sets of brackets here, those are going to be things that have relatively low or low concentrations of acids or low concentrations of bases. And they aren't going to be anything too terrible for you. When we get towards the 3s, the 2s, and the 1s, you are going to end up in a situation where you have, if you consume something that's a pH of 3, or you let that sit on your skin for a really, really, really long time, it's probably not very good for you, or if you drink too much of it, okay? If you get something that has a pH of 2, and especially a pH of 1, that's going to be really bad for your skin. So, like I had kind of said, I'm going to go back just a couple slides. Sorry here. Sometimes you click a little bit wrong. If you get something that's more towards the strongly acidic side, if you have it in contact with stuff on your body, that can cause problems. I would say the biggest thing that you're going to run into day to day is going to be drinks. So most of the drinks that you will consume are going to be on the acidic side of things, and they tend to be somewhere in the high 2s for their pH to the 3s, and some of them are in the low 4s. And drinks that are in the low 4s tend to be okay, but drinks that are in the pHs of 3, what they actually do is they can kind of dissolve the protective enamel on your teeth. And if you have a lot of that, or you drink a lot of acidic drinks, I know some of you really like your Mountain Dew or your energy drinks or things like that. If you drink a lot of them, what that can actually do is it can weaken your teeth and potentially cause decay. And so what they suggest doing is, either if you drink a lot of soda, you could drink it with a straw. Not the most environmentally friendly thing, but if you drink something with a straw, it actually takes the liquid past your teeth and just kind of straight down your throat, and that tends to be a little bit better for your teeth. They also recommend, after you drink some soda, that you should drink water. What you should not do, though, is after you drink soda, you should not brush your teeth immediately unless you drink water to kind of rinse it out, because it's actually kind of an interesting thing. If you do that, and you brush your teeth right away, you're actually brushing your teeth more with the acid than regular water, and so you got to be careful. The same thing can be problematic if you deal with stuff on the extreme basic side of your pH scale as well. We'll kind of pop ahead here to this scale. On the high end of things, you see a chemical here called sodium hydroxide. And sodium hydroxide is a chemical that they call lye sometimes, and they use it sometimes to clean out machinery, but they also use it to make soap. And what it does is it takes fats, which could be, from an oil or a milk or something like that, but it also could be your skin. And what it does is it takes them and it starts to break down the fats in your body and turn them into soap. And so you have to be very careful when you get that on your hand. If you spill sodium hydroxide on your fingers, it starts to feel really slippery, and that's actually because it's starting to dissolve your skin, and that's kind of scary, so you got to wash it off. It doesn't hurt. Interestingly, if you would get hydrochloric acid in a high enough concentration on your skin, that would sting. So acids sting when you get them on your body, and bases don't. So bases can actually cause quite a bit more damage. Here on your scale, you do see the pH of water being neutral as 7 again. And then on the acid side of things, I'm sorry, my dog is barking. There's neighbors or something outside. You'll see a lot of foods here. One of the few foods that is basic are eggs, and their shell especially is basic. Baking soda is basic as well, but mostly bases tend to be like cleaners and things like that. When we look at our acids, like I said before, if I go from a pH of 6 down to a pH of 7, that is actually a change in concentration of a factor of 10. So going from a 6 to a 7, no, I'm sorry, a 6 to a 5 means that there is 10 times more acid in the pH of 5 than there is in the pH of 6. And if I'd go from a 5 down to a pH of 3, I'd have 10 times more concentration when I go to 4, and then another 10 times more concentration, and 10 times 10 is 100. So it's actually 100 times more concentrated. And that's why when you eat a food like a banana, it's not nearly as bad as it would be if you would drink a lot of vinegar or a lot of orange juice or something with a lot of acid. Like I said, it could ruin your teeth. It also, if you have a lot of acid, can cause heartburn, and it can cause sores in your mouth, so you need to be careful. And it's something that, again, as you maybe age or you have problems with certain foods, you need to adjust your diet to accommodate for all of the acid that you are consuming. There is kind of a weird hoaxy diet that's going around. Some of you guys may have heard it called the alkaline diet. And we are going to, I guess, we aren't maybe going to take a complete look at the alkaline diet, but what the alkaline diet says is it says if you eat certain types of food, it will keep your body from going acidic with its blood, basically. And the thing is, your blood is designed to resist changes in pH. And it would take extreme amounts of acid for your body to actually go into this state that they say all of your foods cause. And if you look at the foods that they talk about in the alkaline diet, it's kind of just crazy what they're talking about. Another interesting thing I found actually on the internet the other day was someone's claim about foods that could potentially help you beat COVID-19. And actually, your assignment for later on this week is going to be to take a look at the claim that these people are saying are what's happening, and we're going to see if what they have holds any water or not. So hopefully this kind of clears up pH a little bit. Again, if you're talking about pH, it's the extremes that are dangerous for you. Most foods tend to have pHs that are in the acid range. Very few foods are in the base range. And like I said, you're going to try an activity. I'm going to give you a big list of pHs of common foods, and you're going to take a look at those and see if you can suddenly find this miracle cure for COVID-19. So good luck and have a good day.